Second reason is to use the line to predict the value of y given a value of x. Okay, when you know a specific value of x, it'll let me predict what y will be. The predictor is the x-axis, and the predicted or the response is the y-axis. Okay. So we have some real data. It's actually a couple years old now. I think actually not all the sandwiches are even offered at McDonald's anymore. But on the paper I just gave you is some real data of calorie and fat for some sandwiches at McDonald's. And I've graphed it for you. You can see what it's going to look like. What I want you to do is I want you to answer questions 1 and 2. I want you to describe the trend, strength, and shape. And I want you to draw a line, make it your ruler. So I want you to do it well. Draw a line that you think fits the data. Make sure that the line goes through at least 2 points. You draw the line you draw. Okay. And then back to see if you remember stuff from like Math 1. Can you, if you're given 2 points, write an equation of a line? You all remember how to do that? So do that. Make sure your line goes through 2 points. At least 2 points. Then use those 2 points. Find the slope. Use the slope to find the y-intercept. Okay. It's okay to have a different line than the person next to you. Have at it. y2 minus y1 over x2 minus x1 for your slope. equation, you write what the slope and y-intercept means in the context of the problem. Those are 2 points, 505, 0.65. Yes, what's your slope? Once you find your slope, plug it in with one of your x and y points and solve for b. So the y equals mx plus b. Once you get your equation, tell me what the slope is in context of the problem. Tell me what the y-intercept is in context of the problem. Okay, let's talk about the trend, shape, and strength of the graph. What's the trend, shape, and strength? What'd you say? Strong, linear, positive. You all agree? There seems to be some relationship there. Trend is positive, it's headed in the positive direction. Shape is linear, it doesn't really have a curve to it. The strength is pretty strong. There seems to be some pretty clear relationship between the two. Okay? So here was the line that I drew for mine. All of yours can be different. It's fine. It's no problem. Mine's not necessarily right. And there it is. So my equation I got was y equals 16.25x plus 87.5. Now as you can see, we got two of them that got the same as me. Very impressive. A lot of you have very different equations. Just depends on what 2 points you chose. Okay? So what does this mean in context? The slope for every fat gram added to a sandwich, approximately 16.25 calories are added. in my case, or how many ever, whatever your slope is, would be your number of calories that are added. And the y-intercept would be that a fat-free sandwich has about 87.5 calories. Do both of those make sense in the context of the problem? Yeah, so be careful because sometimes when you look at the slope and especially the y-intercept doesn't always make sense. Like for instance, if my y-intercept had been negative, I would say that doesn't really make sense that I would have negative calories for eating a sandwich, right? So we would want to address that. Whenever the y-intercept doesn't make sense, you should say, this is what it means, but it doesn't really make sense. Okay, you should always kind of state that doesn't make sense in the real world. Yes?
One of there's
a negative? Yeah, so this would be an example where if this is the right equation, negative 50 would mean that if I ate a fat-free sandwich, it would be negative 50 calories. So let me just eat a bunch of those. Sounds like a good plan for the day. So that would be one where you would still say what it meant, and then you would say it doesn't really fit into the context of the problem. Does that make sense? All right, jump back to your notes. We'll come back to this in a minute. Roll with me. Okay, so there are two types of predictions that can be made. There's extrapolation, and in that case, I'm going to make a prediction about a value that falls outside the range of the actual data. So if you think back to your homework you did last night, or well, hopefully you did it on Friday night, but some of you might have done last night. We were talking about the height of kids between the ages of 2 and 7. So extrapolation would be if I chose somebody outside of the ages of 2 to 7. If I talked about a 16-year-old and tried to use the line that I created for that ages 2 to 7 to say how tall a 16-year-old would be. That would be extrapolation. Interpolation is when you make a prediction of an x value that falls inside the range of actual values. So if I chose somebody between the ages of 2 and 7 and use that to predict what their height would be, that'd be interpolation. Which one do you think is better? Interpolation for sure. You talk about extrapolation, go back to those heights. You talk about like a 50-year-old, you plugged it into the same equation that somebody ages 2 to 7, their height, 50-year-old would be like 20 feet tall, okay? So definitely interpolation is the better route to go. Okay, so we're gonna make some predictions based on our equation. So based on the equation you came up with, I want you to make some predictions. Go back to your McDonald's data, a little bit over to the back side. Okay? So you're going to predict how many calories a sandwich with 20 grams of fat would contain, and how many one with 50 grams of fat would contain. So just plug in 20 and 50 in for X and solve it.